is nothing but, if you remember this, f of x plus h, limit of h approaches 0, f of x plus h minus f of x divided by h as h tends to 0. So, if you remember the first principle, this is what is exactly first principle. So, when I say first principle, it is also sometimes said as ab initio, or you can also say by definition. It means the same thing. Okay. So, let us begin with this now. So, if now question is this, sir, in formula you can directly apply the formula and get to the basics of it, right or not. So, how it happens to be that first principle I don't know. If with first principle, it is a solving of limit sum, nothing different. Okay. You are done in continuity differentiability, but still I will show you. This is one value, this is another value. So, if you know these two values, place in this and solve as though it is normal limit sum. So, let us begin with this part. I will show you both the ways, because you might ask me a question, sir, can we do the same question by u by v? Of course, you can do. Of course, you can do, because this is u upon v, and I will just show you whether the answer also comes correct. So, I will verify the answer both the way. So, first let us do the first principle, because they are asking you that only. So, f of x plus h, because if you see the formula, I need f of x plus h. So, f of x is already given to you. F of x is 2 minus x upon 4 plus 3x, and f of x plus h, replace x by x plus h, replace x by, see f of x plus h, replace x by x plus h. So, this will become 2 minus x plus h divided by 4 plus thrice of x plus h. I think I am very clear. Now, you have the first value, you have the second value. Place these values in these formulas and go and solve as those normal limit sum. I am not writing that by first principle and all that stuff. So, you can just write on y dash or dy by dx is limit of f of x plus h. So, I am just opening this out, divided by, be careful, no mistake, plus 3x plus 3h minus fx, sorry, it is 2 minus x. Be careful, because 2 minus x upon 4 plus 3x, I think much clearer to us now, right? Okay, as h approaches 0, do not forget it. Upon h, so this you can put a bracket here and say upon h. Now, if you see the numerator has a multiple fraction. So, what is the best way to deal with LCM process, right? Okay. So, let us see this part. So, I am just trying to find the LCM directly. Okay, if you if you feel confused, I think you go strictly as what you are comfortable. So, y dash, limit of h approaches 0, LCM is 4 plus 3x plus 3h into 4 plus 3x, this denominator h will come to denominator, and it will be 2 minus x minus h into 4 plus 3x minus 2 minus x into 4 plus 3x plus 3h. A big calculation, because 2 into 3 6, 6 plus 6 12 terms are there. I really don't know what is going to happen as we go on. But anyway, have patience. I told you in the beginning, in derivative you need to have patience and work with the simplifications to the way you feel comfortable. Okay, don't jump, you will commit mistakes. Let us see. So, y dash, limit of h approaches 0. I take this up here. Now, hold on, I am just multiplying now. 2 4s are 8 plus 2 is 6x minus 4x minus 3x square minus 4h minus 3hx. Okay, right. Now, what I am going to do is I will just write this properly. Wait. Okay. Now, why I did this, I will tell you. Now, this denominator I write here, that is 4 plus 3x plus 3h into 4 plus 3x into h. Now, hold on. I have opened up this, then there is a minus sign here. So, I put a minus sign. I am writing this simplification here, so that whatever you can eliminate there itself. Minus is outside, so don't confuse. First solve the inner part, otherwise you will do mistakes. Okay, 2 4s are 8, 6x, 6h, minus 4x, minus 3xh, and once again minus 3x square, and x into 3h is 3. Okay, I think that's 1 2 3 4 5 6 3 6 12, correct. Now I'll just simplify and cancel whatever possible. 6x minus 6x will get cancelled, 8 minus 8 will get cancelled, minus 4x plus 4x will also get cancelled, minus 3x square plus 3x square get cancelled, then wait, minus 3hx plus 3xh will get cancelled. I think what is left out now? I got it. So what is left out now? Only these two terms are left out. I will show you. Y dash will be limit. Remember, don't forget to write this because you are not taking the limit. In this minus 4h, outside is minus. So minus 4h minus 6h. What is minus 4h minus 6h? Minus 10h, right? Upon what will happen now here? It will be same thing, 4 plus 3x plus 3h into 4 plus 3x into h. Now I can eventually, before taking the limit, in fact you can take this, cancel it out. Now I think I can take the limit because denominator will become a non-zero number. So you can say taking the limit. Taking limit, what happens now? Taking limit, y dash will be, numerator is minus 10 upon, see what is happening, h is tending to 0, don't miss, x is not tending to 0, h for height, right, h is tending to 0, 4 plus 3x plus 0. Upon 4 plus 3x. You know why? Because there is no h in the other thing. So it is y dash will be minus 10 upon 4 plus 3x whole square. My God, the sum is so huge, but the answer is so simple. Not solution, but answer. Okay, it suits better. Now you might ask me a question. So if you do u by v, are you going to get the same answer? 100% yes, you are going to get the same answer. You want to verify that? Okay, let us verify this part. I am directly doing u by v, so see what happens. Okay, so you know this is u and this is v, 2 minus x. So y dash v square v derivative of u minus 1 minus u derivative of v. Simplify this, see what happens. So y dash will be minus 4 minus 3x, then minus 6 plus 3x upon 4 plus 3x whole square. So gets cancelled. So minus 10 upon 4 plus 3x whole square, same answer. So which one you prefer? If I ask you, give you a toss or give you a choice in the question paper saying first principles to do it and do this method, which one you do? This method. Of course, for your calculus throughout derivative and integration, you don't stick to first principle, you are just going with this. In case they ask you question, using first principle you have to do it, I think then it's you have to do that particular thing. Okay, I hope you got this point clear. Okay, so this is the pattern, this is the way. So instead of saying solution, you can just say answer, because sometimes okay, correct. Oh, I hope got this point clear, right? So it's a nice question, children. So pause and note it down. I don't want to do this. This is just for your build your trust in first principle. To build your trust in the first principle, I verified this particular way. Okay, so take it down and we'll go to the next question. Let us take this question now, y is equal to x plus. Now here you have to remember the power rule is very, very important. Whenever in function the power is there, you have to apply the power rule first. No choice. Okay. So let us see these cases now. Y is equal to x plus root of x square plus 1 raised to n. So bring the power down. Now listen very carefully, because first apply the power rule here. So y dash is equal to n times x plus root of x square plus 1 n minus 1. Work doesn't stop here. This is the derivative of power into chain rule, the derivative of this, derivative of the inside function. Now I purposely written this step, very important. First, this is the power rule I applied. First outer derivative and then go inside. Now let us do it. So y dash, in fact this is n of x plus root of x square plus 1 raised to n upon, now this raised to minus 1 I can write down, x plus root of x square plus 1. Because this see a raised to m minus n, I can write a raised to m upon a raised to n, is the same thing. So I did that. Why I did that I will tell you, just because there is a derivative I can cancel. Even though you don't know, later on you can do it, no problem. Into. Now derivative, now hold on, 1 plus or minus individual term derivative, 1. Root derivative, what is the root derivative we had seen? What is the root derivative? 1 upon 2 root x square plus 1. Root of something, what is the derivative? 1 upon 2 root that thing into inside function 2x. Great. I can cancel this out. I think I can find the LCM and try to work out here. Let us see what happens. So y dash is n x plus root of x square plus 1 raised to n divided by x plus x square plus 1 into. Now when I find the LCM, what happens? LCM will be x square plus 1, root of x square plus 1, cross multiply. Now you will understand why I took that down. I will apply that rule, because if you see this now, x plus, there is a multiplication sign, x plus root of x square plus 1 x. So this completely gets cancelled, and what is left out, that will be the answer. Nothing to simplify more. Okay, I will just write this point clearly. So y dash will be n of x plus root of x square plus 1 raised to n upon root of x square plus 1. This is my answer. So not much to deal with it. So even though you don't do it here, later on you will come to know, because when you apply the chain rule, this is important for me, you have to understand, okay? Because chain rule application, root of something is 1 upon 2 root that thing and go inside. So chain rule, always you go inside and then find the derivative. That's the point. Okay. So I hope you got this message clear. That is the important step which I want to share. Otherwise the sum is really a cheeky sum, right? So pause and note it down. Good sums today. We are going to do very good sums today. So please pay attention. Oh, again, y is equal to, see, okay, in many questions I have not mentioned it. They are asking find dy by dx, okay? Find y dash. So I am not mentioning it because we are doing derivative, that's why we are just going at that. So find y dash, so find dy by dx. Actually, I should mention it when it is a complete screen part. Okay. Now, that will be a mess if you are going to find the derivative u by v. Okay, there is no first principle now. U by v is not, don't do it now, okay, because first is you see the function, right? You see the function says find y dash, okay, or dy by dx. Function is very complicated in nature, but roots are there. I can always stick to my basic mathematics. See, any function, any topic in 11, 12, wherever you meet maths or maths meets you, any function you can always simplify without looking at the question, whatever question, wherever level, whichever level. Okay, that is your right, because it doesn't lead you to a different solution inside. So anyway, coming to a point, if I see a lot of roots here, so what I would do is, I would really try to work out rationalization, the numerator, that would be better. So let us see. So if I rationalize the denominator, because the denominator will go out, root of x plus 1 plus root x minus 1 upon root of x plus 1 minus root of x minus 1 into, now rationalize the denominator now, by rationalizing factor will be same term with opposite sign, x plus 1 plus root x minus 1 upon x plus 1 plus root of x minus 1. So a minus b, a plus b. So a minus b, a plus b can work out that way. Okay, now y will be is equal to a minus b, a plus b is a square minus b square, x plus 1 minus x plus 1, and this is nothing but, I am not talking about derivative in any way. Now do the simplification, because I told you first simplify this out, x's gets cancelled, now it becomes a little bit easier for me, just see. So y will be is equal to a square plus b square plus 2ab. Remember, root of x plus 1 into root of x minus 1, that is root of a plus b into root of a minus b will be root of a square minus b square, okay, don't forget that, upon, this is 2. So y eventually will be, this will get cancelled, 2x, 2 gets cancelled, so x plus root of x square minus 1. So if you, not y dash, I am sorry, this is just the simplification here. Now this is something very important which I want to share, because the function after simplifying change to this. So tell me, that finding derivative of this is easier or this is easier? I think this is easier, correct or not? I hope you understand this. 2x plus 2 I took common from the numerator and the 2 gets cancelled, and this is what the function is, and then finding the derivative is more easier than anything else on this earth. What is the derivative? Y dash will be, derivative of x is 1 plus root derivative, root of anything is what? 1 upon 2 root that thing, minus 1. Oh. Sometimes I am also a human being, so it works out, difficulty, not difficulty, sometimes some error creeps in, maths is something, I hunt it down many times, but sometimes I get hunted. So 1 upon 2 root x square minus 1. If you want, you can simplify this out, otherwise you can leave it as it is. So if you want, if you can simplify, y dash will become 2 root x square minus 1, 2 root x square minus 1 plus 1. So this is my solution. So I hope you got this. So instead of doing u by v directly, I simplified this by rationalizing the denominator, because once I rationalized, the function became more simpler, correct or not? The function becomes simpler and you give a smile, right? And then you started taking the derivative, it is much easier to deal with this rather than that. So I hope you got this point clear. Children, let us look at the second question quickly. Next question, I know the second question. Next question. Continue.